Now we're going to go through some probability techniques. The first thing we're going to look at is Venn diagrams. Now, just a quick hint, when filling in a Venn diagram, it's generally the best idea to start in the middle and work your way outwards. First example, in a school year of 60 students, 32 study geography and 40 study biology. If 18 study both of these subjects, find the probability of a randomly selected student studying neither geography or biology. We're going to start with drawing a Venn diagram. Now with a Venn diagram, you have to remember to draw the rectangle on the outside of the Venn diagram. Within an IB exam, that can actually lose you a mark. So make sure you always draw the rectangle. Now we've got two subjects, geography and biology, which means I'm going to have two circles. One for geography and one for biology. Now we've got 60 students, so I'm just going to write 60 on the outside. That's not necessary, but I always like to do it just so I've got the reference there of how many I should have in total. Now I start in the middle, which is if they study geography and biology. Now in the question, we can see we have 18 of these. It tells us 18 study both of these subjects. Now we know that 32 study geography. Geography is this whole circle, which means the 18 is also included in that. And now because we have 32 that studied geography, that whole circle has to add to 32. Within geography, that would be, only geography would then be 14, because 14 plus 18 makes up 32, and we know 32 study geography. And then we know 40 study biology, which means we've already got 18, so 40 minus 18 is 22. So we have 22 that study only biology, but with the 18 that study both, that makes up the total of 40. Now from this, we need to know how many students don't study either of them, which would be a number that we would write on the outside of the circles. So to work this out, we know we have 60 in total. We would need to minus all the numbers we already have in the diagram. And that would leave us with 6 left over, which means 6 are on the outside of the circles in the Venn diagram and 6 don't study either. The question though is asking us to find the probability. So the probability of neither. So the probability of neither subject. We can't just write 6 because that's the total amount. We need the probability. So the probability of neither would be 6 out of 60, which would be 1 out of 10 or 0.1 as a decimal. So always make sure you read the question to know if you wanted to just find a number in a section or if you're needing to find the probability. Next, we're going to look at tree diagrams. So these are used when you have one event followed by another, and particularly when the second event depends on the first. It's just a really nice way of visualizing what is happening and then to be able to get the right probabilities to find out your answers. Example 2, in a city, the probability of it raining is a quarter. If it rains, then the probability of travelling by car is 2/3. If it is not raining, then the probability of travelling by car is a half. Find the overall probability of travelling by car. So we've got two things happening. We've got the probability of it raining and then the travelling by car. So in a tree diagram, we would have our first lot of branches. Now this would be for if it was raining or not, because that's the first thing that's going to tell us what we're doing next. So if it's raining or not raining. So if it's raining, the probability of it raining is a quarter, which means the probability of it not raining is 3/4. Now remember, on each set of branches, the probabilities have to add up to 1. Then our second lot of branches off each of these, which would be the probability of car, travelling the car or not travelling the car. So we'll have car or not car, car and not car. Now if it is raining, the probability of travelling by car is 2/3. So raining is this first branch, so we carry on there, that would be 2/3. So the probability of not travelling by car would be 1/3. So remember, one set of branches, probabilities have to add up to 1. Then the probability if it's not raining, the probability of travelling by car is a half. So a half of the car, which also then means it will be a half for not travelling in a car. So that is our tree diagram for this. Now, what is always a good idea with a tree diagram is to then work out our outcomes and our probabilities. Often just makes it much quicker when we're doing our next step. So this outcome will be rain and car. This will be rain, not car, not rain, travelling in a car, not rain, and not travelling in a car. To work out the probabilities of these, when we're working across a tree diagram, we multiply. So rain and car would be a quarter multiplied by 2/3, because that's the path we take to go, it's raining, and then we travel in a car. So that would be a quarter times 2/3, which equals 1/6. A rain and not car, so which would be a quarter for the rain and multiplied by 1/3 for not travelling in a car, which equals 1/12. And then we do the same for not raining. So not raining in car would be, followed through the diagram, 3/4 times by 1/2. And the last one, not raining, not car, would be 3/4 for it not raining times by 1/2 for not travelling in a car, which equals 3/8. Now in this question, we are asked find the overall probability of travelling by car. So we need to look at our diagram and go, which of our outcomes is travelling by a car? So which one just has a C, which will be the first one and the third one. These are our two options of travelling by car, which means we need to use those probabilities. So our probability of travelling by car would be 1/6 plus 3/8. When we're working across a tree diagram, we multiply. Once we have our probabilities and we're working with our outcomes, then we add. And so the answer to that would be 13/24. Next, we're going to look at sample space diagrams. So sometimes the easiest way to record all possible outcomes is in a sample space diagram. So we've got an example. I'm going to show you two different types of sample space diagrams that you could see. Just depends on the situation, and IB could really show you either of them. In this situation, two fair standard four-sided dice are rolled. Find the probability that the sum is larger than 6. The first sample space diagram I'm going to show you is with dots. I'm going to have 1, 2, 3, 4, because it's a four-sided die. And so we could roll a 1, then a 1, then a 2, and we're just going to put dots of all the possibilities we could have. So this one, like a 1 and a 3, a 2 and a 3, 3 and a 3, 4 and a 3, etc. Now the other way of drawing a sample space diagram is actually to have your outcomes put in it already. So we would have dice 1, and our options would be 1, 2, 3 and 4. Then we'd have dice 2 down the side, and our options are 1, 2, 3 and 4. And this would actually include the outcomes. So if we rolled a 1 and a 1, you're adding the sum of the dice together, so the answer there would be 2. Adding 1 and 2 would give a 3, 1 and 3, 4, 1 and 4, 5. So it's just adding the two numbers together in the corresponding squares. So that's two different sample space diagrams and how you could use them. Now for this one, we said find the probability that the sum is larger than 6. So the easiest way with this one would be to use a second diagram. So we want the sum being larger than 6, which means we only have 3 options, which I've circled there. Now in the first diagram, you do calculation just quickly. So we've got 4 plus 4 is 8, 3 plus 4 is 7, and 4 plus 3 is 7. So with those 3 options in the first diagram. So then in this one, we want the probability that the sum is greater than 6 would equal, now we have 3 possible outcomes there that fit that situation over how many total outcomes. It's a 4x4 grid, which means we have 16 possible outcomes. That's how sample space diagrams can be used. Lastly, we're going to look at two-way tables. So the following table shows the interaction between the type of book and size of book in a random sample of library books. First of all, we want to find the probability that a randomly selected book is fiction. And then part B, a non-fiction book is randomly selected. Find the probability that it has 0 to 200 pages. Now, when you have a two-way table, one of the first things you are always going to do is include the totals for each column and row. So you might have to redraw it. You could just extend a table, which is what I'm going to do right now. So I'm just going to extend these tables, and I'm going to put the totals. So for this first row, we've got 23 plus 3, which is 26. 28 plus 6 is 34, and 8 plus 12 is 20. And then I'm going to add the columns. So the first column for fiction, we have a total of 59, and non-fiction a total of 21. Then in the bottom corner is our total of everything. So if you add up all your totals in the row or column, you should get the same number, and in this situation is 80. So we've looked at 80 books. This is just going to help us now with our probabilities. So part A, find the probability that a randomly selected book is fiction. So we look at fiction, we've got fiction here, and our total fiction book is 59, so the probability of it something being fiction is going to be 59 out of our total, which is 80. Then part B, a non-fiction book is randomly selected. Find the probability that it has 0 to 200 pages. So we know we're picking a non-fiction book, which is going to be the 21, and what the probability is 0 to 200 pages. So we've already selected the non-fiction book, which means for this one, the probability that it's between 0 and 200, given that it's non-fiction. So we already know we've picked non-fiction. So with that one, you just have to read the question, and that one would be 3 out of 21.